You're starting at 17, and I know you can read, so I'm not going to read out the questions to you. You might want to hit pause and read them when I get to the next one. In 17, if the car is starting from rest, then the initial velocity is 0. Here's the acceleration. It tells me plainly. I'll label that A. How far will it go must be a distance, and here's the time it took to do it. I need a formula that has all those things in it, except, well, maybe I can skip VI, because it's got a 0 value, so maybe we can skip that. Let's look through our formula list and find something that uses those variables. Here we go. Here's something that has what we need. Except remember, VI will be 0, so when I multiply it by T, I'll still get 0. And this term will disappear because there's no point in adding 0. So I just disappeared it. We put in our terms. We know the value for A. We know the value for T. My most common mistake is to not square the 2. I'll forget the squared entirely, or I'll square the S and not the 2. So let's be careful there. This 2 gets squared, this S gets squared. The S squared then will cancel this S squared, which is good because, what's the units for distance? It doesn't have time in it, right? I know people cheat and say I lived 5 minutes from here, but really a distance has something like meters or miles or kilometers or something. It doesn't really have time in it. So the time needs to cancel out, and in fact it does. And a half of 6 is 3 times 4 is 12 meters. On 18, if the rocket goes from rest, we have a VI, an initial velocity of 0 again, and it reaches this final velocity, at least for the span of time I want to talk about. And here's my span of time, and what's the acceleration is the question. So we're going to be solving for A. We need a formula that has these units in it. Go to your formula list, and it turns out we can use this. Except VI is 0, so you can write it down or not. It doesn't really matter. I put it in this time just to be different this time. And really all we have to do is get this number away from A. Well, how do you get rid of the number attached to the unknown, like X, or in this case A? You do the opposite. So we'll do the opposite through the equal sign, and we'll get 15.2 divided by 1.2, and we'll get 12.7. And then somebody's kind of screaming, well, no, the S's will cancel. Why do you have S squared? Well, what we really have is meters per second divided by, and S, any normal number or variable, is really over 1 if we want it to be, isn't it? So this is not cheating. This really is true. S is S over 1. So what we can write is meters per second, a fraction, divided by S over 1, another fraction. And how do you divide by a fraction? If you think back to 6th grade or something, they said multiply by the reciprocal. So if you write it out like this, it becomes more obvious that the S's don't cancel. They in fact multiply and become squared on the bottom. And I'm hoping that at this point we're starting to get a memory here that acceleration is in distance per time squared, and in this case meters per second squared.